In the endless and uncontrollable universe, the sun is like a bright pearl, exuding endless light and heat, becoming the core and master of the solar system. However, a seemingly absurd and indifferent problem quietly emerged. Can the sun be extinguished by water? Regarding this whimsical question, the answer is that solid water cannot extinguish the sun. From the deep analysis of theory, even if a super large amount of water is used. To explain this more thoroughly, let's explore a hypothetical situation together. If 400 billion tons of water are poured on the sun, what kind of shocking changes will it cause? Based on data obtained by scientists after long and hard exploration and careful estimation, the mass of the sun is about 200 billion tons, equivalent to about 2 multiplied by 10 to the power of 34 kilograms. In this way, the mass of 400 billion tons of water is almost twice that of the sun. If we simply imagine the sun as an unusual, large burning fireball, we may naively think that such a large amount of water would inevitably extinguish it. However, the energy generation mechanism of the sun is not the kind of ordinary combustion process that we know in daily life, but is derived from the extremely complex and fierce nuclear fusion reactions inside it. This mechanism is essentially different from the common combustion phenomenon. Through persistent observation and in-depth research, scientists have clarified that the high temperature of the sun is staggering. The surface temperature alone can soar to about 5,500 degrees Celsius. In such an extremely high-temperature environment, if it is only a small amount of water, for the large scale of the sun, no liquid can exist. The water will instantly turn into gas, and the powerful and unparalleled heat energy will destroy the original stable molecular structure of water molecules, decomposing them into hydrogen and oxygen. However, when we consider 400 billion tons of water, the situation changes significantly. Although the heat released by the sun is immense, compared to such a shocking amount of water, it can only vaporize a small portion. Under the omnipresent and powerful role of most of the water, the vast majority will condense with a thunderbolt, quickly becoming a liquid state, and then forming an outer layer on the sun. This sudden sink will have a significant impact on the surface temperature of the sun, causing a sharp decline. At the same time, this layer will act like a heavy curtain, effectively covering the light of the sun's outward radiation. From external observation, the sun will appear to be extinguished for a while. But we need to understand that this is just a temporary surface phenomenon. The vital nuclear fusion reaction inside the sun will not stop abruptly due to this outer water layer. To understand the mystery behind this phenomenon, we must realize that starting a nuclear fusion reaction requires the high temperature support provided by the sun's internal structure. The high temperature is not derived from an external combustion process, but from the massive heat generated by the sun's own gravitational collapse. From the internal structure perspective, the temperature distribution shows a unique trend that gradually increases from the inside out. Only in the core region of the sun, the core reactor we know well, can the necessary harsh conditions for starting the nuclear fusion reaction be met. This newly generated outer water layer will not reduce the temperature of the sun's core, but will significantly increase the sun's total mass. With the sharp increase in mass, the sun's gravity will intensify, generating more heat. This change will have two key impacts. Firstly, some regions in the sun's internal structure that were outside the core reaction area will now reach the temperature threshold for starting a nuclear fusion reaction due to the sudden temperature rise. This means the core reaction area of the sun will expand significantly. Secondly, the rate of nuclear clustering reaction is highly sensitive to temperature changes. With the significant rise in the core temperature, the rate of nuclear aggregation reaction will increase sharply. When these two effects combine, the final result is a sharp surge in the energy released by nuclear aggregation inside the sun. Based on existing star models that have been repeatedly verified, if the sun's mass suddenly increases by 400 billion tons, the energy released by its internal nuclear fusion will increase by about 70 times. Under such a wave of energy release, it won't take long for the outer water layer to vaporize, transforming into a plasma state and decomposing into a large amount of hydrogen and oxygen. These elements will integrate into the sun, becoming part of the new sun. However, the energy released in the core reaction area of the sun will form a barrier, preventing materials in the outer layer from entering the core reaction area. Therefore, the newly added hydrogen and oxygen will not directly participate in the nuclear fusion reaction. Based on mature star models, further estimates suggest that the new sun will reach about 1.5 times the radius of the current sun and emit higher energy levels of blue and white light. Here, it is important to mention that the greater the mass of a star, the higher the consumption of its internal nuclear fusion fuel. Therefore, when the sun's mass increases significantly due to the influx of water, the new sun's lifespan will be significantly compressed and shortened. According to authoritative speculation in science, With a significant increase in mass, the new Sun will enter a completely different evolution period after tens of millions of years due to core fuel exhaustion, evolving into a red superstar. The outer material of this red superstar will gradually be lost outward, eventually forming a vast planetary nebula. The residual core will undergo complex changes and gradually evolve into a white dwarf, marking the end of its glorious yet relatively short life journey. Therefore, even if we pour 400 billion tons of water on the Sun, it will not be extinguished. Instead, it will experience a series of intricate changes, eventually evolving into a larger, hotter, brighter, but shorter-lived new star. From a theoretical perspective, if we continue to pour more water on the Sun, the underlying logic remains the same. However, when the water increases the Sun's mass more than 8 times its original mass, an extraordinary and severe change will occur. Under this extremely special and rare situation, the new Sun is likely to encounter a core collapse supernova eruption at the end of its life, one of the most spectacular and fierce celestial events. The energy released will be enough to illuminate the entire galaxy. When exploring the interaction between the Sun and water, we cannot be satisfied with surface-level analysis. We need to understand the deeper scientific principles and cosmic laws. From the perspective of material and energy interconnection, the interaction between the Sun and water is like a grand cosmic drama, showing the wonderful conversion of substances under extreme conditions. This process reflects the vulnerability and variability of matter under strong energy impacts. The increase in energy due to water integration highlights the dominant position of energy in celestial systems and its effect on material state and celestial evolution. Analyzing this assumption from the perspective of star evolution, it opens a unique window, allowing us to view the life cycle and evolution path of stars from a new perspective. Conventional cognition sees star evolution as a slow and stable process, but external factors like massive water addition can significantly change this rhythm and destination. This phenomenon warns us that in star evolution research, we must consider external environments and interference factors. Observing the interaction between the Sun and water from a cosmic materials cycle view helps us understand solar evolution possibilities, like material ejection in the red superstar stage and white dwarf formation. The release of substances and energy is crucial for galaxies and new stars and planets' birth. Through in-depth research on such phenomena, we can understand the deep laws of material and energy conservation and transformation in the universe and the wonders they create. Scientific methods and thinking encourage us to explore novel assumptions and ideas, revealing the essence and internal laws hidden under appearances. Innovative thinking methods starting from anomalies and extreme conditions can break traditional thinking frameworks, bringing new opportunities and breakthroughs in scientific progress. In future scientific exploration, improving observation technology and theoretical models will deepen our understanding of the Sun and other celestial bodies. We will provide more accurate and convincing explanations of interactions like the Sun and water, supporting the exploration of the universe's mysteries. Returning to the core theme of Sun and water interaction, we can explore its potential application in other scientific fields. For example, in energy research, understanding and controlling nuclear fusion reactions are key to achieving clean energy. The Sun's natural nuclear fusion process provides a unique laboratory. Detailed research on nuclear fusion reactions in Sun and water interaction can inspire innovative technical methods, achieving breakthroughs in controlling nuclear fusion and addressing the energy crisis. In planet science and extraterrestrial life research, understanding water's presence in different celestial environments and its interaction with stars is crucial for evaluating planetary livability and life existence possibilities. If similar star-water interactions occur in other galaxies, it will deeply impact surrounding planets' formation and evolution, affecting life, birth, and survival conditions. These issues deserve more research and exploration. In cosmic structure research, star evolution and material distribution relate to the universe's overall structure and evolution. The Sun-water interaction, significant changes in mass and energy can subtly affect the galaxy's gravitational field and material flow, influencing galaxy formation and development. Through in-depth research on microprocesses and macro phenomena, we can understand the universe's structure and evolution laws, building a solid foundation for cosmic theories. Whether the Sun can be extinguished by water may seem simple or bizarre, but it contains rich scientific knowledge and philosophical insights. Scientific research and theoretical analysis of this issue deepen our understanding of the Sun and stars, stimulating curiosity and exploration of unknown phenomena in the universe. In pursuing scientific truth, seemingly incredible issues can unlock new scientific fields and discoveries, expanding human knowledge and deepening our understanding of the universe.